Welcome everybody to today's seminar. That's absolutely fantastic to have Professor Hashmi with us to be able to talk to us for the next 40 minutes or so, following which we will have a question and answer session. If at that particular point you could start putting your questions into the chat box, and then we can have a nice discussion after this. I'm particularly grateful to him for starting off this series of fellows talks. I hope that everybody finds all of these interesting, informative, and takes us to different places that we haven't necessarily thought of in the past. So without further ado, I'm going to hand over to Professor Hashmi to take us through his talk, which is about metals in Pakistan, with particular look at metals that are arising from surgery. Thank you.
Thank you. Thank you very much, Gillian, for your invitation and kind introduction. First of all, I would like to congratulate Professor Akinet, the president of C, and Professor Andrew for initiating this valuable seminar series through C fellows, by inviting C fellows. And I would like to share my presentation. Can you see?
I can see that you started screen sharing. I'm hoping it'll come up in a moment. Sometimes they take a little bit to.
Can you see the slides?
No. It says that you started screen sharing, but the slides are not yet coming up. Olivier, maybe this is one for you.
Perhaps, Mohammed, if you stop your video, it will help with the sharing.
Yes,
I'm not sure where it's gone because it was there a few moments ago.
It would also be nice to remove the background so as to allow the bandwidth seems to be low.
I apologize. I apologize.
No, go ahead. It's understandable.
There we go.
Fantastic.
Can you see that?
Yeah, we can see that now.
I have my video. Okay. So the title of my talk is the status of heavy metal contamination in different environmental compartments from Pakistan. Before I start my talk, I would like to provide the basic information regarding the background. So in Pakistan, you can see here, Pakistan is 6th highly populated country in all over the world, and with lot of different anthropogenic activities. We have so many different industries that are located in this part of Pakistan. I just want to open the pen. In this part of Pakistan, it is a highly urbanized part of Pakistan. It has some industries, some agriculture activities. This part of Pakistan is highly mountainous areas with less population, with less industries and less agriculture activities. This part of Pakistan is another province, and it has more people, highly urbanized part with more vehicle activities, some industries that are located in this part of Pakistan, and some agriculture activities. Similarly, this part of Pakistan is also highly urbanized, and it has some industrial activities, some agriculture activities. So beside this, recently, within 5 years, you can see here that China-Pakistan economic corridor has been launched. From this part of China, they are building some construction from this route to this part, the Gawadar, this part is located here. This is the port. The Chinese government is developing some ports. So there is a lot of construction of roads throughout Pakistan just since the last 5 years. So this type of contamination is existing in Pakistan. So in this map, you can see here that how the different industries are located throughout Pakistan. You can see there are some different industries like cement industries, ceramic industries, cotton industries, some glass industries, iron and steel making industries. You can see here that where these industries are located in Pakistan: jute industry, leather industries, some match development industries, paper and board industries, shipbuildings, silk and rayon industries, sugar industries, vegetable ghee industries, and woolen industries. These industries are polluting the different environmental compartments in Pakistan, such as they are polluting, they are just polluting the atmosphere. They are untreated, they are putting the untreated waste into the riverine bodies, into the irrigation soils, in the soil, and also the different human beings are exposed through different industrial activities. So to monitor such pollution, my team and our group just developed some novel biomonitoring tools to monitor the pollution, the state of pollution in different environmental compartments of Pakistan. So this was our first paper, and in this paper we just sample the eggshells from the cattle egrets and the little egrets. These egrets are used for food purpose in Pakistan, and they are just located in the agriculture areas of Pakistan, the cotton belt of the Pakistan, in the Punjab province. And in the map, you can see here that these are the study sites. We collected the eggshell sample from these sites, and these sites are mostly the urbanized sites, some agriculture activities, and all the rivers pass through these sites. So in the results, you can see here that these sites were, we divided these sites based on the different land use type. The Shore Court, this was a site, it was highly urbanized. Malsi, it is agriculture. Jhang Faisalabad roadside, this is agriculture side. Trimu, it was a headworks. Islam, it was a headworks. So we collected two egret species. One was cattle egrets. It mostly feed on the vegetables, and the other was little egrets. It's food little bit of some vegetables and some insects, some other animals. So you can see here that manganese, lead, and the zinc, three metals were mostly highly, the higher concentration was found in the suburban areas due to their traffic activities, some industrialized activities that are present. However, all the metals were, most of the metal was significantly distributed among the sites, except and were some results, and it suggests that eggshells of the egrets could be used as a biomonitoring agents for the environmental contamination in Pakistan. Then we figure out the relationship between different metals and use the correlation analysis and the principal component analysis to find out the relationship of the different metals. So you can see here that nickel and lead was highly correlated with the manganese. So the results suggest that these are coming from the similar sources. Iron was correlated with the lithium. This is mostly some natural sources. Copper was negatively correlated with the cadmium. Nickel was also correlated with the lead. Pp was correlated with the lithium. So this was the results. These results were also verified by the Varimax factor by PCA principal component analysis, that and suggests that the same correlation suggests that these metals were coming from the similar sources. Then we apply the ANOVA one-way analysis of variance to find the site difference, the species difference. So you can see here that iron and the manganese was highly significantly different between the species. Manganese higher concentration was found in the little egrets as compared to the cattle egrets, and the iron higher concentration was found in the cattle egrets as compared to the little egrets. So Box and Whisker Plast, based on the site, suggested that almost it was significantly different. Manganese was significantly different between different sites. Lithium was also showed a similar trends as compared to the other metals. Then we apply the hierarchical dendrogram cluster analysis by using the word linkage method and Pearson correlation distance matrix to find out the grouping of the different metal for source identification. So in this cluster analysis, you can find here that we found the three different groups. So these three different groups suggest that these metals are coming from the same sources. For example, the manganese, lead, cadmium, and nickels. These are mostly the automobile activities, some electrical activities. Lithium and the iron, these may be the natural sources. Zinc, chromium, and copper, these are some agriculture activities, some industrial activities. The sources of these metals suggest that these are coming from these sources. Then we used egg of these two species, egret species, to monitor the egg contents, to monitor the environmental contamination in Pakistan. We use two sites, the two headworks. One is the Islam headworks, and the another one is the Trimu headworks. These two sites are used for the irrigation purpose. These headworks are used for the irrigation purpose and figure out the heavy metal concentration in the egg contents. So based on our results, it was suggested that difference, all the metals were significantly different between the Islam headworks and the Trimu headworks. And however, the concentrations of the iron, copper, manganese, lead, and zinc was more in the Trimu headworks as compared to the Islam headworks. Based on the species, the one-way analysis of variance revealed that copper, manganese, chromium, and lead was significantly different between the species. It was our results. Then we used the correlation analysis, and based on the correlation analysis, it was found that manganese was correlated with the copper, and it was positively correlated. Cadmium was negatively correlated with the copper. Lithium and copper was negatively correlated. Manganese and lithium was positively correlated. Chromium and cadmium was positively correlated, suggesting that these are coming from the same sources. So based on the different headworks, we compare this graph, compare the comparison of concentration of studied metal in the egret species in the Islam headworks and the Trimu headworks. So you can see here that in the Islam headworks, the concentration of manganese and the copper was higher in cattle egrets as compared to the little egrets, and the comparison between the species at the Trimu headworks revealed that the concentration of copper and the manganese was higher in the cattle egrets as compared to the little egrets. So we use the cluster analysis to figure out the correlation between the to figure out the sources of the contaminations of the heavy metals. So you can see here that the cluster analysis revealed 3 groups. In our previous paper, same sources are coming from these metals: lithium, manganese, and coppers are coming from the same sources. Group 2 revealed that cadmium, chromium, zinc, and nickel are coming from the same sources. And group 3 suggests that lead, copper, and iron are coming from the same sources. Then from the same sites, we used the feeders. Feeders as a biomonitoring agent for of cattle egrets and the little egrets for heavy metal contaminations. These sites are located in the Punjab province of Pakistan. This province, as I have already informed you, that it is highly urbanized with lot of agriculture activities and industrial activities. So the results suggest that for the three sites, Trimu Headworks, SH, and MNA, Melseed, we have 3 sites. We choose 3 sites, and the results suggest that among the 3 sites, these metals, cadmium and iron, chromium, and lithium was significantly different among the sites. And as compared to the other sites, so the concentration of the manganese, lead, cadmium, lead, zinc, and cobalt was higher in all over the sites, suggesting that the high contamination of these metals in these sites. We use the correlation analysis, and in correlation analysis, it was suggested that cadmium was correlated with iron, and iron was correlated with the zinc, and negatively correlated with the cobalt. That suggested that they influence, they are coming from the same sources. Then we showed the result of one-way analysis of variance through the box and whisker plants, and you can see here that at different sites, the different metals were significantly distributed. You can see here that iron was significantly distributed among the sites. Lithium was also significantly distributed among the sites. Cadmium was significantly distributed among the sites, and same case was found that chromium was also significantly distributed among the sites. Same results also found the nickel, manganese, and the cobalts. Then we applied the cluster analysis for the sources of the metals, and you can find here that 3 groups suggest that these 3 metals are coming from the same sources. The group 1 suggests that these are coming from the industrial sources. The group 2 suggests that these metals are coming from the automobile activities, and the group 3 suggests that these are coming from the agriculture activities in Punjab province of Pakistan. Then to monitor the heavy metal contamination in Pakistan from 2 headworks at Baloki and Rasul Barrage, we used novel the Ganges soft shell turtles, and these are successfully, we found that these could be used as the biomonitoring agent for heavy metal contaminations in the riverine bodies. We use different parts of these turtles, and you can find in the table that the distribution of different heavy metal contaminations, and overall all the metals were significantly distributed amongst the different parts of the turtle species, except the iron. Iron was non-significantly distributed, And you can see here that highest concentration of cadmium was found in the Balochi barrage, in the kidney of the turtles. And also the lead was also higher at the Balochi barrage, in the kidney of the turtles. However, the concentration of the zinc was higher in the hearts at the barrage Balochi. And you can find here at the barrage Balochi, the liver showed the maximum concentration of the cobalt, copper, iron, and manganese. Similarly, in the plastron at the Balochi barrage, the concentration of the chromium and the nickel was higher. So the results suggest that the Balochi barrage was highly contaminated as compared to the Rasool barrage in Punjab province of Pakistan. And the highly contaminated organs of both of the Ganges soft shell turtles were the kidney and the liver. So this is another our study, and this was conducted in the Rawal enclave of Rawal Lake of Pakistan. It is located in Islamabad of Pakistan. And this lake serve as the water of this lake serve as for the drinking purpose for the people that are living in the Islamabad and Rawalpindi city of Pakistan. So we used some edible fish species to monitor the status of the heavy metal contamination in the Rawal Lake Reserve of Pakistan. So we collected 4 species of fish, these species of fish, and you can find here
Mohammed, we seem to have lost your voice, I'm afraid. I don't know whether you are able to bring that back again.
Oh, sorry for the internet was disconnected. I'm sorry for this.
That's absolutely fine. Don't worry. Given everything that's going on at the moment, I'm surprised that you're actually managing to keep connected. So please don't worry about it.
Can you see the slide?
Not yet, but we can see that you're trying to screen share. I don't know if Olivier is still with us.
I'm sorry again, the net was disconnected.
Don't worry. Don't worry.
Can you see the slide?
No, not yet.
Not yet.
No. We've got it. Yep. It was there for a second.
I'll share again. I'm going to share it again. Can you see now?
Yes, that's it. We've got it. Thank you.
Very much. Thank you very much. I was just telling you that how the different edible fish species can be used as a biomonitoring agent for heavy metal contamination of the fresh water. And you can see here the trends of the different metals in different fish species, and we collected some different parts of the different fish species, such as the skin, muscles, gills, kidney, and the liver. And you can see here that iron was present at higher concentrations. Lead was also present in higher concentrations. Cadmium was present at higher concentrations. and same case was the nickel as compared to the other heavy metals in different fish species. So this is our another study, and in Pakistan, this site is located in the highly industrial area of Pakistan. You can see, I can just show through pen. This area, this is a Sialkot in the industrial area in Pakistan. Maybe many of you are the lover of the football. You see the football FIFA World Cup and the football. The FIFA has purchased the football from this city of Pakistan. This city of Pakistan manufactured the football for the FIFA and for the football. So we use
Excuse me, please, if you're not actually presenting, please could you mute yourselves, because there's an awful lot of disturbing background noise. It's very unfair to the speaker. So if you could just please mute yourselves for a wee while, that would be very helpful. Thank you. Do please carry on. Professor Hashby, do we have you still with us? We can see your screen, but I can't hear you.
I'm again sorry for disconnectivity of the internet. Can you see the slides?
Yes, thank you.
Thank you very much. And we use the different organs of the two frog species, and then we compare the results between the industrial sites and the non-industrial sites, and you can see here that the different organs, the liver, the stomach, kidney, heart, lungs, and the skeletal muscles of Rana tigrina species, the higher concentration of these metals in the industrial sites as compared to the non-industrial sites. And some metals, like you can see here that iron was significantly distributed in the liver, and cobalt and nickel was significantly distributed in the stomach, and there was non-significant distribution of the metal in the kidney, in the heart. The chromium was significantly distributed, and for the lungs, the nickel was significantly distributed. So these are the trends that the heavy metal concentration was higher in the Rana tigrina species of the in the industrial sites as compared to the non-industrial sites. So this part of the table showed the result. Another species of the frog, the distribution of different metals, eucalyptus, and you can find here that the p-analysis, probability analysis showed that most of the metals were non-significantly distributed. And however, the contamination at the industrial site was maximum in different organs of the eucalyptus frog species in the industrial city Sialkot of Pakistan as compared to non-industrial site. Same trend also found here, that for different metals, and these were the some just status of the heavy metals. Then we studied the another arsenic, the distribution of arsenic and the exposure of arsenic from groundwaters in the Lahore district of Pakistan. So this is the Punjab province, and in the Punjab province, this is the Lahore city, and we collected the different sample from this city. This city is highly urbanized. This city has industries. However, the underground water due to bedrocks is also the main cause of the environmental contamination of the groundwaters. And we used the different samples for adults, some children, some old age peoples, and we collected some blood samples, nail samples, hair samples, and the urine samples, and determine the arsenic concentrations. So you can see here that in adults, the concentration in nails, the concentration of the arsenic was higher. However, in hair sample in the adults, as compared to the children and the old age peoples, suggesting that adults are highly contaminated and have a risk for the arsenic. So then we determine the risk for arsenic contaminations, and for which sample has more risk for arsenic, such as blood, hair, nail, or the urine sample. So in this graph, you can see here that the high risk is found for the nail samples and also for the urine samples, as compared to the other samples. Other samples showed the low risk. So this suggests that this type of risk is present in the after exposure to the arsenic. So this is a Basque diagram of arsenic for studied groups selected from low risk, medium risk, and high risk areas. In the blood arsenic concentration in 3 groups for 4 sites, and also this is the A, and B is for the urine, and C is for the hair sample, and D is for the nails. So you can find here that these are the different sites. This is the control sites, Kulwawa site, Mega Mafi site, and Chung sites. And you can find that here that the distribution, the box and whisker plots show the significant some distribution of the arsenic in different samples from different sites. So this is the mean concentration of arsenic in biological samples, and it showed that the distribution of arsenic in the urine from children, blood, hair, and the nail samples. And you can find here that the blood samples, hair samples, and the nail samples have more concentration of arsenic as compared to the urine samples in the children's, in adults, and the old age peoples. Then we use a correlation analysis between some antioxidant and oxidative stress enzymes and some blood, urine, and hair and nail samples. And you can see here that the hair and nail samples are correlated, and GSH activity was negatively correlated with the urine and also with the nail samples. GPS activity was negatively correlated with the nail samples, and GR and catalase also showed some negative correlation. However, catalase showed positive correlation, and GR showed positive correlation with the GPS activities. This is the PCA based on the Euclidean distance biplots, and it showed the distribution concentration of arsenic in different age groups, and these are some results. Then this is the distribution of the some oxidative and antioxidant enzymes based on after exposure to arsenic in different in children, adults, old age pupils. Then we use some other heavy metals, the level and the distributions of the heavy metals and changes in oxidative stress indices in human from Lahore district, same sites, and we then studied the other heavy metals. And you can see here that in different, the analysis of variance showed that lead was significantly distributed among different age groups as compared to other heavy metals. However, the contaminations of the lead, zinc, and chromium, and also the cadmium was higher as compared to other heavy metals. This study was done in the blood samples. And similarly, also we calculated the risk of these metals, and you can see here that the p-value showed that all the metals distributions, and some metals showed low risk, some showed the medium risk, and some showed the higher risk in the human blood samples. So these are the studies for the human urine samples, the distribution of the heavy metals among the different age groups, and chromium was significantly different among the children's, adults, old age. However, the higher distribution was recorded for the lead and also for copper and the iron as compared to other heavy metals. So then we calculated the risk of different metals. This table showed the risk of different metal present in the urine samples. Similarly, the distribution of the table 5, the distribution of human heavy metals in human nail samples, and all the metals were not significantly distributed, but some metals like lead, iron, zinc was highly, the levels of these metals were higher in the nail sample as compared to the other samples. This table shows the risk of these metals based in the human nail samples, and similarly, these are the distribution of these metal in human hair samples. We used as a hair sample as a biometric agent, and you can find that 3 metals were significantly distributed, such as cadmium, manganese, and the zinc. However, the higher concentration of zinc was zinc, iron, lead, and cadmium was present among these different groups. Table 8 suggested that showed the risk of different metals in the human hair samples, and you can easily see here that some type of a risk of some metals is present in the human hair samples. So these are some antioxidant enzyme activities, and these figures suggest that after exposure to the heavy metals, the oxidative stress and antioxidant enzyme expressed in the human blood samples. This was the correlations, and some metals were highly correlated with the oxidative stress and the antioxidant enzymes. So this is another study, and it was published in the Ecological Indicators, and we studied the heavy metal distribution and then calculated the risk assessment and water quality using water quality index in the river zone of Pakistan. This is the study area map. This is the site. It is located at this part of Pakistan, and these are some sampling points you can see here. And the sampling point also in the closer view, you can see here that these are some different sampling points. So we use some models, water quality index, and some other enrichment factors, and then we figure out the risk assessment and water quality of the river zones. Basically, this river is located near the city of Peshawar, and this city of Peshawar city is highly urbanized. Beside this, it has some industries, the industrial effluents, this river received the industrial effluents and some contamination from the from the domestic city of the Peshawar. So then you can see here that we compare the results between the pre-monsoon and post-monsoon for different sampling points, for the water physicochemical properties, some heavy metals, and we found that pre-monsoon has a lower concentration of the heavy metals, and the water quality was good in the pre-monsoon as compared to the post-monsoon. Heavy metal concentration was lower in post-monsoon. However, in pre-monsoon, the heavy metal concentration was higher from different sampling points. So these are some water physicochemical parameter comparison between the pre-monsoon and the post-monsoon season. Total phosphate you can see here at sampling point 12 and 13. Both pre-monsoon and post-monsoon showed the higher concentration of TP. pH was higher at some points in pre-monsoon. However, at point 17 and 15 and 16, the pH was higher after post-monsoon season. You can see here the comparison of the different metals among different sampling points. Lead was higher in pre-monsoon. Manganese at some points was higher at pre-monsoon. Nickel was higher after post-monsoon. Chromium was higher after post-monsoon. Total nitrogen was higher after pre-monsoon, and however the other trends of the metals you can find here. So these are the physicochemistry of heavy metals in the suspended and bed sediments of the river zones, and these are the suspended sediments at different heavy metal concentrations. These are some sampling points, and you can see here that some metals were present at higher concentration at some points, such as copper and iron, and lead and zinc was present at higher concentration as compared to the other metals in the suspended sediments of the river zone. If we see the trends of the heavy metals in the bed sediments, the concentration was lower as compared to the suspended sediments. However, manganese was present at higher concentrations. Iron was also present at higher concentration as compared to the other heavy metals. So this is another graphical representation of geo-accumulation index, enrichment factor, and potential risk index for suspended and the bed sediments. And you can see here that this comparison revealed that the cadmium, lead, nickel, copper, and the chromium showed index higher value of index of geo-accumulation. However, some metals such as cadmium, lead, nickel, copper, and chromium showed higher enrichment factors, suggesting that these metals enrichment was higher in the sediments of the river zones. So figure 3 just revealed the spatial temporal variation in the nutrients, pH, organic matters in the bed sediments in 2 different seasons, and you can see here the significantly dynamic trends in the physicochemical properties distribution among the among the pre and post monsoon seasons. This was the table 4 showed the risk classification of suspended and bed sediment and water quality index of river zones, and the different sampling points showed different risk. For example, some sites showed the moderate risk. Some sites, some points, for example, the points 5, and 6 showed the considerable ecological risk. Some sites, for example, the high risk was present for the site 14. The 14 sites showed the higher ecological risk, and also same case was present for the site 16. 16 sites and the 14 sites showed the higher ecological risk of as compared to the other sites, suggesting that these sites receive more contamination from the industries, maybe some agriculture point, and some contamination from the urban city, Peshawar city, which is located very near to the river zones of Pakistan. This is another paper, and we just the distribution, risk assessment, and source identification of heavy metals in surface sediments of river zones.
Excuse me one moment, please, Professor Hashmi. We don't have a lot of time left, and I'd like to give people the opportunity to ask some questions. So if we could move on, if you've got some major conclusions, that would be brilliant.
Okay. Thank you very much. Thank you very much for your kind reminder. So this was another study. It was highly cited, more than 500 citation for this articles, and this is another study. So these are the trends of heavy metals in the industrial cities of Sialkot, in surgical instrument industries of heavy metals in different humans. So these are some trends, and this is leather manufacturing industries in Sialkot. So this is my research network, and just I want to conclude that as I told earlier, that Pakistan is the 6th most populated country. It has some industries, some agriculture activities, and some geochemistry, some natural presence of the chemicals in the geochemistry. So based on our results, we use some novel biomonitoring species such as frogs, some fish, some turtle species to figure out the trends of heavy metals. Then we use the riverine water to find the contamination of heavy metals, and we found that some sites were highly contaminated, and which needs dire attention from the government, from the environmental organization in Pakistan, to devise policies to control these pollution. Thank you very much for listening. If you have some question, you are feel free to ask the question from me.
Thank you very much indeed for a very interesting talk. That was splendid. Thank you. I did actually suggest earlier on that people put their questions into the chat box, but there doesn't actually seem to be anything in there. So I'd like to use chair's privilege and start some questioning myself, and maybe a few people will stick their hands up and want to ask some questions too. I'd like to know.
You can drop question.
Pardon?
You can drop the question in the chat, no problem.
Okay, but I will ask you directly. The egrets are very, very similar to each other. How were you convinced that you've got a difference between the little egret and the cattle egret for both feathers and eggs?
Thank you very much for your very good question. Actually, you see that the feeding habitat of both species is different.
Okay.
Little egrets eat vegetables and also some insect. When we visit the site and when we collected the samples, then in the ground we saw that little egrets, in the feed of the little egrets, there was some insect. But when we collected the sample of cattle egrets don't eat the insects. So based on these two feeding difference, our study reported that the difference of heavy metal could be due to the different feeding habitats.
Okay, thank you. And until we get something else that comes in, I've got another question for you as well, please. Do you that's a lot of research that you've got there. How is any of that going to feed into government policy in terms of pollution prevention?
Thank you. Thank you very much for your technical question. Actually, in Pakistan, if I honestly speak, we have the laws, but there is a lack of implementation in the laws. We have government organizations such as EPA, Environmental Protection Agency, in every province, in every district of Pakistan. We have a Ministry of Environment, and we have some good capacity building through institutes. But when I see there is lack of responsibility from both sides, our society also is irresponsible, and the most of the industries belongs to politicians, some rich persons. So it becomes very difficult. It becomes very difficult to impose the law, to impose the rules and laws on politicians. And similarly, the government organization EPA is functionless. They have all policies, they have all rules, but it is unable to pose some stringent strict regulations on the pupils. So that's why I think that in Pakistan we have some serious issue of environmental pollution.
Do you see that changing anytime soon?
Sorry, maybe change.
Yeah.
Yes. Actually, our last government, the Prime Minister Imran Khan, he was famous cricketer. So in his campaign, during his political campaign, his main objective was that how can we build or how can we clean our environment. So he tried a lot, and he just frustration in Pakistan. He developed the idea of frustration in Pakistan, and in KP province of Pakistan, there is a lot of huge frustration. They just initiated this project, and I think as a teacher, I always mobilize students that we should be careful, because this Pakistan is related to us. If our students have some ideas, some training, some skills, then I think in near future it is possibility that we could get change. People are changing.
Okay, thank you. I can see a question in the chat box there,
Yes.
and that's
thank you.
from.
Ask a question.
Do you have baseline geochemical data on the environmental media before using the biomonitoring techniques?
Yes, I think in some parts, not in all Pakistan. We have a baseline natural background value and some baseline geochemical data. Some parts. I am living in Islamabad. Islamabad has Himalayas forest, Himalayas mountains. For the Himalayas mountains, we have the baseline geochemical data. However, for other in Pakistan, for other environmental compartments, we don't have the data.
Is it possible for you to be able to access, not access, create a database of that? Or is that a very big thing?
It is possible. Yes, thank you very much for your kind and valuable suggestion. I think it is possible. Maybe in future, my research group will do the research. Right. One of my colleagues in another university, at Quaid-e-Azam University, at Department of Chemistry, he is generating such type of data, the baseline geochemical data. However, you have provided an additional idea to me, and I am very grateful for your kind question and suggestion. And in future, I think that I will think about this, that I should create some baseline data for Pakistan. Thank you very much.
Oh, that's a big task. We have another question here. I'm afraid I'm likely to mispronounce this, but I'll have a go. So Alawadimilola, apologies. Thank you for the lovely presentation. The use of human hair and nails as biological samples is quite interesting. What's the rationale behind using them in these studies? How do you get them? Are they from cadavers or are they from living beings? any challenges while trying to get the samples, and do they undergo any specific processes? So there are several questions in there. That's almost another presentation in its own right, but if you'd like to address it, that'd be great.
Thank you. I am very grateful to Dr. Fagede for asking the very interesting question. And I would like to summarize all questions in one answer. Of course, it is very difficult to get the hairs and the nail sample from the human beings. Sometimes it is very challenging. Most of the people don't agree that we don't provide. But in Pakistan, sometimes it is very easy to get these samples. You know that we collected these samples from the Lahore city of Pakistan. And sometimes when the students go there and they motivate the students, they motivate the volunteers, some persons over there, that if you provide samples, then it will be very good for that we can get the status of the contamination in you, and we can devise some policies. This is one question, one reason. And another reason is that my students belongs to Lahore. So it was very easy for him that he went to his relative, and the relatives were agree to provide the samples of hair and the nails, and in this way our sampling was very easy. So I think that you can also try, if you want to figure out the heavy metal status from your country or from your area, so you can use this type of strategies to collect the sample from the human beings.
That's great. Thank you very much indeed. I can't see any more questions coming in, so we've just got a few minutes left. Is there anybody else who'd like to stick something in the box quite quickly or wants to put their hands up?
Is there any question from anyone?
Feel free to unmute yourselves and ask straight on at the moment. I will take that as a no. So that's a really great presentation. Thank you for all the information that you have just given to us. A reminder to everybody that this will actually be on the SEGH website. So if there's anything that you want to pick up again, then you're going to be able to do so. And I'd just like to say a huge thank you. And we look forward to the next presentation. The date is on the website. I can't remember what it is off the top of my head, sometime in October. But thank you very much indeed for starting us off. That's a great presentation. Thank you.
Thank you very much, Gillian, for your great words. And it is because of you and Professor Akinet and Professor Andrew. You have initiated a great thing, and I think it will be a great source of learning to the early career, some other scientists all over the world. Thank
you for your kind words. Okay, I'd like to say goodbye to everybody. I'm about to switch off. Thank you. Okay, thank you. Bye-bye. Bye-bye. Have a great day. Bye-bye.